Hello, everyone. Welcome to the next portion of NGINX Sprint. I'm Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT. As you heard at the beginning of NGINX Sprint this morning, the Tech Field Day delegate community has been part of this event last year and this year, and we've been watching the presentations and discussing it. You've probably seen some of our commentary on Twitter using the NGINX Sprint hashtag, and we've been really absorbing the information from today. So it is wonderful that we have the opportunity now to bring to you a bit of an interpersonal live discussion about NGINX Sprint and some of the topics that have been brought up today. Joining me, in addition to the Field Day delegate panel, which you can learn more about by going to techfieldday.com, we have Gus and Rob, who you saw this morning at NGINX Sprint, to answer questions from the delegates and from the folks who've been interacting as well during the event and on Twitter. So we're going to start off with Nick Genitakis asking the first question of Gus. Go ahead, Nick.
Hello. Hey, Gus. Thanks again for sponsoring this event here. Question for you. Let's say I'm an organization. I'm already on AWS. I'm using EKS there, and I'm using the AWS load balancer controller. Why should I move over to using the NGINX ingress controller in this case? Are there some advantages of that one?
Yeah, great. Thanks, Nick, and thank you all for making the time to be a part of Sprint. First of all, I'd say there's probably three key areas. The first being really just in the data plane itself. We've made a lot of investments, particularly in load balancing algorithms, in things like rate limiting, the additional metrics and capabilities that we get out of commercial NGINX Plus. And so those sort of data plane capabilities are typically more rich in features and capabilities than the native ingress controller that you're going to get from EKS. Second area is around authentication. We've put a lot of effort around NGINX as an API gateway, so token authentication and so forth. So being able to use NGINX to be able to authenticate traffic and authorize usability to certain apps and services on the back end. And then the third area where we're seeing a huge amount of uptake, specifically for our ingress control capabilities around security. Now that we're part of F5, one of the great benefits of that is that we've been able to port the firewall capability that sits on top of Big IP and move that across on top of the lightweight data plane of NGINX, and we've ported that capability also into our ingress controller. So to be able to have a firewall at the ingress gives you that additional level of security. More and more we're seeing zero trust becoming an architectural pattern or approach to how we're building our applications, and having security not as a perimeter, but security at every hop in that data plane is critical. So being able to put that at the ingress into a Kubernetes environment is just another layer of security that you can provide closer to the left, closer towards the applications in the containerized environments. So the data plane feature-rich capabilities, the authentication capabilities, and then security.
Okay, thank you.
I would jump in with that, with the question being, since we're talking about security, and for me in the cloud, security is all about identity. How are you handling all the different identity types that you might find in AWS or Azure or even on-prem? Is it all certificates, or are you bring some unique capabilities around that identity management component?
Well, I'll take a first stab at it, and then Rob, you can feel free to jump in. But we integrate very tightly with all the other identity tools out there, whether using Okta or Ping or native identity services within AWS or any cloud provider for that matter. And so we make sure that we integrate with the third-party tools that people are using. And then we've obviously got the identity features that we've talked about within NGINX, such as jot tokens and so forth. Rob, you want to extend on that?
Yeah, sure. I mean, I think you bring up a good point, which is our role in the ecosystem is more the identity awareness. So we're not the identity store or policy itself. We'll integrate with some of the tools within the F5 portfolio. There's what we call our APIM, our Access Policy Manager, which can sort of be that definitive identity store. We just want to be that intelligent control point that sits closer to the application to code. So, JWT authentication is increasingly OpenID Connect. Things like that are going to be what we want to honor and kind of keep the chain of custody, if you will, from an identity perspective, all the way up to. And you combine that with encryption, and that's where we can really get more into the zero trust, where we're doing things like mutual TLS all the way up to the proxy, whether it's a sidecar or running at the ingress layer.
Thank you for a great event. I have a question for Gus. So you were describing those waves and how NGINX have evolved over time. So something that I was wondering, and I'm thinking maybe I'm not the only one, was this artificial intelligence and machine learning in the wave 3. So could you elaborate a bit more on that? How will the NGINX fit onto that picture?
Yeah, absolutely. Thanks, Kari. It's an exciting extension of my role since joining F5. Obviously, I still am part of the of looking after NGINX with Rob, but I've extended my focus into the artificial intelligence and data aspect of F5's technologies. If you look at the role that both Big IP and NGINX play, we're in that privileged position of being in the data plane of traffic that's routing in and out of every critical application within a customer's environment. And so as you think about that, there's certain telemetry and information that you see and get access to that we can share with customers and use that in a more deeper and beneficial way. If you think about how typically when you look at metrics and analytics, it's looking like in the rearview mirror. You're looking at problems that have happened in the past. So if you look at the management planes that Rob sort of described, the layers there, at the management plane level, you're looking at trending analysis. Typically, you're looking at what's happened in the past. You're trying to find what went wrong, and you're trying to get a sense of at least how to fix that to do root cause analysis. Where the future is and what we really want to be able to do is more predictive analysis. So, one great example that I talked about was the weather. You don't often want to ask what the weather was yesterday. You want to know what the weather is going to be in a few days from now. And by taking that telemetry that we have and not just doing it at the data plane level or at the management plane level, but putting that into a deeper data lake where we can do deep analytics on that using ML and AI capabilities, we can start to do predictive analysis of what your application may be doing today, tomorrow, or a week from now, or even further out. And through that, we can start to plan what automation or infrastructure you may need for specific events. And as we see them happening in real time, we can correlate that and transform your application infrastructure so that you're able to handle spikes in traffic. You're able to see in real time security threats happening and prevent them from being more dangerous throughout your entire application environment. So we're taking the telemetry we have in Big IP, the telemetry we have in NGINX, and through our firewalls and putting that into a centralized data lake, doing that AI and ML and feeding that information back into our management planes and giving that capability back to our customers so that you can do more deep analytics. And so in the future, we want to extend this not just to the infrastructure and looking at how you can automate your application so it grows and shrinks and heals and defends itself in real time. But we want to be able to do more around the customer journey and the workflow of a customer using your application so that they're more efficient, more so than just looking at maybe round trip time. You can actually look at how long does it take for a customer to buy a car or get that car registered or get financing for that car. And if that's the customer journey across multiple applications, tracking that journey across all those applications and giving you more of a business outcome than just technology outcomes. And that's ultimately where I think this is going to go.
Hey, Gus, I'd just like to jump in. I'm Paul Stringfellow, and thanks for having us here today. I appreciate it. And so I suppose for somebody who's relatively new to this space, one of the things that interests me is lots of what you've just talked about, and I think you just hinted at it in that last answer, but obviously lots of the things we can do here, you could potentially do natively inside of existing infrastructure. So at what point as an organization would I need to get to before I start to consider NGINX? Why would I be looking at you? What are additional things you bring in, and at what point should I be considering that?
Well, I mean, if you're looking at NGINX broadly, then one of the great things is through the fact that we're part of the open source community and have open source tools such as NGINX, using Nginx, as soon as you get your application and want to talk to the outside world, outside the container or outside your application, Nginx is a proxy. And given that it's free and open source, you would use this at the development stage as you're developing your application, just to test that you're able to communicate with the outside world and be able to receive requests and answer those requests. So that's at the sort of very early stage, and you could do that. Many of our open source users use this from that early stage all the way through to running massive web scale infrastructure like Dropbox or Pinterest or any of these large web scale companies that have been using Nginx for many, many years. Where you start to use our commercial version, things that we offer there, is where you want to do less of the self-management of the open source project and add third-party modules and do all the integration work, or you want advanced feature capabilities like the ones I mentioned around API authentication or security. If you want to up level to having management tools that help you orchestrate and manage your environments, to have an API abstraction layer, so to config changes, you can do them through API calls like Rob mentioned in his talk around Instance Manager. Where you want to get these advanced analytics and metrics that we're talking about with the AI capabilities in the future, that's where we're making it easier for people to really grab the power of the Nginx data plane without having to be a deep dive expert on how to configure 700 plus directives that are within Nginx to get that power. That's where some of the tools that we're building and capabilities that we've extended with our commercial offerings, I think, really bring the power of Nginx at a data plane level to a broader audience that doesn't necessarily want to be deep dive experts on that, but want that same, concurrency capabilities and performance capabilities and stability that you get by using Nginx as a data plane.
That's a great answer. I was interested at what point do I need to be able to make this kind of investment, and I think the points you've made there around management, around insight, around analytics, and more of that kind of stuff that you want to do. As one of the notes I made through your main presentations were around this idea of kind of taking these modern applications and making them more enterprise-like, more traditional enterprise-like, and maybe that's I kind of in a roundabout way. I think that's what you've just said.
Yeah, and one of the core I've been in open source now since 2003, and one of the things I love about open source is it puts the technology capabilities in everybody's hands. Right? It sort of democratizes technology so that everybody has access, and that's one of the beautiful things about Nginx is that it is free, it is open source, so you can start with it today if you're just building your own home application. There's no reason you wouldn't use it today, but as you get more into enterprise and complex environments, then we're building more commercial offerings to help you in those environments. And we're not doing it just at the data plane level, as Rob announced today. We're extending that beyond the data plane into the management plane and other areas as well.
So, Rob, we saw early on the slide where there was a clear delineation between the F5 side and the Nginx side. But in later slides, we saw some commingling of that, so obviously it's not a black and white situation. Can we go into a little bit more depth as to where we see F5 and Nginx sitting today, and possibly even some, not necessarily roadmap, but more vision as to what the integration longer term there might be?
Yeah, for sure. So a couple different ways to think about that, right? So yeah, I did. I kind of showed it as two almost binary. You've got your traditional applications, big IPs, is sort of the front door in front of that, and Nginx in front of it, modern applications. The reality is we are increasingly working on how we integrate those two technologies because of those kind of gray states that are in between. And so some technical integrations, for example, if you're using Kubernetes as your ingress controller and you're using Big IP as your front-end load balancer and security device, how can we pass information and state, for lack of a better term, back and forth between those two so that any changes to the Big IP are automatically advertised to ingress and applications and users know how to get there? And more importantly, if there's any dynamic changes that are happening inside of Kubernetes, how do we advertise that back to Big IP so that we can automatically make sure that users are directed to the right cluster or the right instance within that cluster, right? So those are examples. We're doing similarly outside of just the Kubernetes use cases. And then increasingly, we're also looking at it from a security perspective, since we are using F5's one WAF type technology, but using it across multiple kind of packages, if you will. It could run natively on the NGINX, it could run natively on BIG-IP, it'll soon run natively in different cloud instances. So that's kind of philosophically. What I would encourage folks to think about, though, is, and I'm going to use a little bit of a stretched, I don't know if it's an analogy or metaphor, but it's one of the two, which is imagine you're walking into a big kind of multi-tenant building where there's 30 floors and there's different users or tenants on all those different floors. Chances are you're going to have a front reception area, and that reception is going to check you in. They're going to point you to the right elevator bank that you need to go to. They're going to make sure that there's any kind of security check they have to do. So in this example, BIG-IP is that lobby. It's performing the ADC and security functionality for the building. But once I get in and I get off, let's say, the third floor, and I walk up to a particular company that's on that, I'm probably going to enter another reception area. They're going to maybe check who I am again. They may guide me to a particular conference room or ask me to sit in the waiting room. So that is a second form of traffic management and security that's happening, but it's happening on a per tenant basis. I think what we're trying to do is make sure those two systems talk to each other. Wouldn't it be nice if when I check into the lobby, the third floor automatically gets a signal that, hey, this person is coming up, a guest is coming up, expect them, so that my identity, so to speak, is passed. Or more importantly, if I'm on the third floor and I want to go visit another tenant somewhere else in the building, I don't want to go all the way back down to the lobby, recheck in, and then go all the way back up, which is what would happen if I didn't have, in this analogy, NGINX running at each floor, if this example makes sense, right? So you need both layers, but you need them communicating to each other. And that's increasingly the signaling we're working on. We're using things within BIG-IP's automation framework, it's called AS3, that connects to the more extensible and kind of infrastructure as code driven way of NGINX. So that was one of the first times I've tried that example out. So let me know if I did okay on it.
That actually is a very expressive way of showing that analogy. It helps paint the picture very well. Yes, I think it was pretty good.
Whew. All right.
All right, Rob, I have a quick question. Well, maybe a quick question. I wanted to dive deeper on the AI and ML. And I wanted to know, it seems like right now, a lot of that AI ML is leveraged around App Protect and the F5 like WAF technologies. When is that going to come, and how is it going to be trained to handle the traffic and performance scaling? Is this something where there's going to be reports back to F5 so that they can anonymize and train models? Is it going to be more reinforced learning? How are we going to keep this thing from going awry in the AI worlds of TAG?
Yeah, no, great question. And there's sort of two ways this is manifesting itself right now. So the first is, if you look at the security context, we want local AI and ML, where the engine is co-resident with the technology, and it doesn't necessarily need to beacon telemetry back to a central point of cloud. And a lot of the reasons why is because if in certain security environments, I don't necessarily want that open connection to some sort of cloud infrastructure, but more importantly, I could be running it in a dark network or some sort of air gap network. And so I need that intelligence to be local. So one area we're investing, which is a little more security specific, is how do I look at traffic and learn patterns over time. A great example would be inside of our App Protect, we have a denial of service module that you can add on, and it may be looking at, for example, your API calls, and it may notice that you're suddenly getting a flood of API calls because of a misconfigured client. Well, it's not technically malicious in that it's not taking care of an exploit, so a WAF wouldn't block it. But I do want to make sure that I maybe tamp that traffic down and pose a rate limit and then observe it over time and see if it goes back to normal. If not, maybe I block it. If it's okay, I can turn it back up. So that would be kind of one where the ML engine in this case is co-resident along with it. But more importantly, bigger term, what we're looking to do is take advantage of a lot of the intellectual property that F5 got with the Shape acquisition. If you're not familiar with Shape, they're essentially an AI ML engine that productized for fraud as the first use case, right? So they're looking at different patterns and looking to say, okay, is this a bad actor who is doing credential stuffing or some sort of nefarious activity? And that is all done in a central where we're actually beaconing information. We can actually look across different instances of Shape across multiple different enterprises to look at aggregate attack patterns. What's exciting to us at NGINX is there's nothing about that engine that then can't be repurposed for non-security use cases, so that we can think about how do we automatically increase capacity during key peaks in demand, or how do we automatically move workloads because of cost arbitrage, or because we want to move to a more reliable infrastructure. So all of that's in place. Now, under it, we're investing heavily in OTel as the open telemetry as the connective standard that will allow us to beacon that information. So even if you don't want to use our technologies, you should be able to beacon to the engine of your choice. And so that's what we're beginning to invest in more heavily. And the key, and last thing I'll just say, because you hit on it, is we want to train that engine to be as reliable and smart as possible. And that's where we get several years of operating Shape as an AI and ML engine. We've learned how to do that with a high degree of fidelity, so that we don't have to worry about Skynet activating and going amok, if you get the reference, right? So those are some of the things that we've learned, and that already works in the most sensitive environments in the world, both for financial and government. So I think we have a lot of confidence in the engine. Now we have to work on the plumbing so that we can take advantage of it.
A little bit of a follow on to that. Are there going to be developer interfaces into these models, or to change the reinforcement learning algorithm in some way that's specific to our applications, or to leverage that data in our applications themselves?
Yeah, I mean, certainly that's kind of the concept, and we'd love to do that, I think, moving forward. I think for now, we're working on a little bit more of where we'll handle that, but we do want to open it up. One of the things that Gus mentioned is we're going to be doing that all in our own data lake, so there's no reason why we can't expose components of that. And so one of the things that we're also going to be working on is, think of it as an SDK or some sort of developer kit, where we can actually not only get access to some of those, but the other element that F5 recently invested in is a company called Volterra, which has an edge computing platform. And so increasingly what we want to do is also make sure that if you're building your application natively on our platforms, then you would have the ability to call on and train those models, because they'd be kind of pre-wired, pre-integrated, similar to how you would automatically get a lot of AI ML smarts if you chose Google Cloud as your underlying cloud. So we're not trying to replicate the cloud infrastructure space, but instead just kind of abstract the delivery and that vision of an adaptive application that Gus was talking about, and make that programmable and extensible. And that way you could actually plummet across multiple cloud as the underlying infrastructure.
I could already feel like how those open source contributors were getting very excited when you announced that there will be 2 new projects. So what is the driver for you for increasing open source development in the future?
Yeah, it's a great question. I'll give you the raw and honest answer, which is we need to get back to our roots. This is what got us here in the first place. And I think if you look at NGINX's journey over time, if you go back to about 2018 or so, we were a standalone company. We were venture backed, and we really needed to prove that we had a viable commercial model. And so the pendulum swung a little bit towards creating commercial intellectual property. Well, fast forward a year, we came into F5 through an acquisition, and now we've figured out our role inside the portfolio, what we're doing to help drive the company vision. We've been afforded a lot of extra resource now that we have our benevolent overlord. And so one of the things that is we can do is invest more heavily in open source than we did in the past. There isn't you have to make revenue and prove to your investors that you've got a model. It's how do we continue to gain relevance and drive value into the modern application environment, which is our kind of mission within F5, if you will. And I think what we're finding there is it has to be a show, not tell. And we really need to get back to demonstrating good open source technologies. We've kind of got our one hit that we did some years back, and now we're looking to put out a few more albums with a few more hits on them. And I think the most important thing is, how do we make sure that regardless of what type of technology we're putting out there, we stick to the ethos of it's got to be lightweight, fast, and flexible, right? That's kind of what got NGINX where it is today. Yes, it's a web server and proxy. That doesn't matter. That's, if I could say, what does NGINX stand for? It'd be those three attributes. And so we want to make sure that we continue to bring that, so that as you build any kind of digital offering, digital service, NGINX should help you keep to that ethos of making it lightweight and fast.
Rob, as a follow-up to that, if you're trying to make it a more inclusive and getting more people contributing to the open source projects, what are you doing to help people get started easily? I know some open source projects out there, you start reading the contributing markdown, you're like, oh, forget it. This is going to be like 20 hours before I can even do one PR. So what are you doing to encourage engagement from the rest of the community?
Yeah, sure. And for those of you who are big NGINX fans, you'll know that historically we've actually used a source code repository called Mercurial, and we actually mirror that to GitHub. But the vast majority of people pull NGINX in today through their standard Linux distribution. So we're actually fairly hands-off from the actual user and the implementation. And so one of the things we had to invest in was great documentation, because we don't know how you're getting it or exactly where you're installing. So in the early days, making sure that we had robust documentation was what led to a better developer experience. I was itching to announce today the two specific technologies that we were looking to put on, but that documentation isn't ready. And so our fear was we wouldn't actually make good on our commitment of putting it out there and making it useful day one. So the most tactical answer is making sure we have a good documentation experience so that developers know how to take advantage of it right away. But we do also want to invest in our community management and our developer relations function, which is just corporate speak for how do we have people out there that are actually meeting where the community is at, whether it's Stack Overflow or Reddit or those places, and actually engaging there. My experience in open source is it's a double-edged sword. Sometimes you don't want to do that because you don't want to give that value away for free, but that's not the stage where we're at now. We want to fan the flames. We want to get things going faster. And so in addition to sort of a self-serve, which is documentation, how do we be a little bit more proactive? And so you'll see us investing in experts that we can embed in the different community sites that are out there and try to help nurture some of the technologies in their earlier stage. And, one that's public, so a great example would be Unit, which is our app server. So that's one where you'll see we've got a good start to the documentation. We've started with some evangelism. So that's one that you'll see is going to be increasing quite rapidly in the coming months.
Great. Thanks, Rob.
Yeah, thanks, Dan.
Hi, Rob. It's Jason here. Thank you for the presentations today. And one of the current core themes that I picked up was there's an increase in adoption across all sorts of the technology stack. And with adoption comes a requirement for a sort of ease of use and a greater simplicity. And I know you started to talk about that on the sort of validated architectures and reference architectures that you're working on, but could you talk maybe a little bit more about how NGINX plans to, help the more basic users or the more beginner users, and then how you can grow adoption as we scale into enterprises that may never have touched these before?
Yeah, great question. And there's two ways I'll go about answering. So first of all, NGINX was named that for a reason. It's an engine. What you choose to do with it, what chassis you put it in, to use an automobile analogy, will determine its kind of use case. But that's all we ever were for a long time, was just an engine maker. You had to build the car. You had to put the engine in, tune it yourself. So increasingly, I think one way we can help with ease of use is help get to that, like I shouldn't say no one, very few people go out to buy just an engine. Most people want to buy a car, whether that's a sedan or an electric vehicle, a pickup truck, will depend on your use case. So we want to help get to that automobile, the finished product, faster. Gosh, I'm using really stretched analogies today. So that's, first and foremost, we want to, that's what we're trying about, open sourcing other components so that you can get that to a finished state faster. So that's on us, and we will do that. But I think implicit to your question is that's great, but there's a whole ecosystem that's needed then to make this work. And that's what we're really trying to do with the reference architecture, which is how do we get to a point where there's a pluggable modular system, but quite frankly, an opinionated one, because I think where we are in the state of a lot of these technologies is they are useful, but you can get yourself into a lot of trouble if you just kind of use them out of the box. There's specific states, tunes, configurations, best practices that are out there if you hunt and peck hard enough, but they're not sort of built into it. So one of the things we're trying to do with the reference architecture is how do we get to that opinionated best practice state sooner? And then you can move it from there. So how do you integrate CI/CDs frameworks with some sort of automation like Ansible or Pulumi? And how do you then automatically connect the right logging and the right telemetry and the right dashboarding? All of this exists with Grafana and all of the different, but how can we get there faster? So for us, there isn't a specific goal to that reference architecture other than how do we get it up and running faster? Because I think it's a barrier to entry, and we built it around the Bank of Anthos, which is Google's sample app for a microservice, to just get it to the point where you're doing something sooner rather than later. And so that's so part of it is, what do we do from a technology perspective to make sure our stuff is integrated? But then more importantly, how do we build a more valuable reference architecture where it's pre-wired, so you're not worried about how to connect the gazintas and the gazautas, but instead you're just trying to say, okay, these are the different functions I may need to tune for my use case. And then making sure that's all, well documented, which is why we want to turn it over to community development for the reference architecture.
That's a great answer. Thank you. And your analogies are spot on today. Thank you.
Whew, good. I'm trying out a lot of new ones here.
I guess I'll jump back in, Rob, because I
Sure.
think we're all kind of curious with this reference architecture. Is your vision that this is something that's actually deployable, like it's a set of Terraform modules or some Ansible playbooks, or is your vision more, I've got an architectural design and some documents that say this is how it should be set up, but it won't actually do the deployment for you?
Yeah, no, great question. And for anyone who wants to see it in more in depth, day 2 tomorrow, we'll be coming and giving a live demo of it all, so you can actually see it in action. It is available on GitHub to pull down today. But no, it's meant to automatically implement all the components and worry about that wiring on your behalf. So it's a reference architecture in that it's an opinionated way to connect all those things, but it's actual deployable code. Now, over time, we want to build out the module library. So if you don't want to use Pulumi, which is what we're using to do a lot of that scripting, then you could use Terraform. If you don't want to use Ansible, then you could maybe swap it out for Puppet or Chef. So there's different things that we'll do to make it modular over time. But the goal is it's deployable today. It builds out the entire, and to be less obtuse, it'll automatically install in our world an ingress controller with the right ingress policies, all automatically kind of pre-wired for the right Kubernetes operators. So it's doing all of that. And the goal was, how do we get this entire application up and running, which is a full, production Kubernetes-based microservices app in minutes. And so really what we've done is the scripting and the glue, and then we're using partners in our ecosystem. And then what we want to do is over time is get folks to contribute, to validate the different components and get it so that you could imagine I just get prompted in the beginning, what are the different packages you want to use? You write those up and it's automatically pulling them from the right repository and building the reference architecture with your particular Lego blocks, to use another analogy.
Cool. Thanks, Rob.
And continuing on that, if folks want to deploy like simpler apps or even function as a service style serverless apps, is this something that you see Nginx getting into and doing more of? Like, AWS, you've got Copilot, where, a couple commands and you've launched, and all the cloud formation stuff's just kind of behind the scenes, you don't see it. Is that an area, because a lot of the things you've talked about have been pretty complex, a lot of service mesh, Kubernetes, all the big things. What about the simple things?
Yeah, and it's a great observation. I mean, Nginx thrives in the sophistication side, end of the swimming pool, if you will, right? So it's the power users who want to get under the hood and eke every last ounce of performance or scale or security by customizing that. To your point, there's a whole population of folks where they would actually prefer not to have that level of detail be something they worry about. Maybe they go under the hood and tune it, but they don't need to worry about it. And so I think our vision for that moving forward is a combination of things. You brought up function as a service. At the end of the day, if I'm a developer, I may just want to put my code in an environment and have that code run reliably, and I just want to do that all via API interface. In essence, that's what our unit app server is, right? I mean, under the hood, it's a polyglot app server. It speaks all different languages, but that's not the point. That was just a means to an end. The end is I should be able to give it my code, and it will know how to give it the runtime environment for that code. And so in essence, it's a do-it-yourself serverless or function as a service entity. It's not tied to a particular cloud platform or a particular infrastructure platform. So that way I can be agnostic to the environment. So if I'm running unit across multiple clouds, or maybe I'm running it on Volterra's Edge platform, then I'm giving my developers that capability, just upload their code. So what we want to do, and kind of what I hinted at, was we want to build all the smarts into unit so that out of the box, it's doing, for example, proxying, authentication, encryption. It could communicate with things like a WAF if you have more complex security needs. And like I said, you can go in and tune it, but it's not necessarily something you have to worry about. So that's our future. Now, so as not to overcommit, that's not really where it is today. Today, it's more of a do-it-yourself, similar to the vein of Nginx of yesteryear. But I think what you'll see moving forward is and working. Part of the reason why we want to do the reference architecture is to learn and to figure out what is the state of the art for folks that crave something that's a little bit easier, and then create that feedback loop into the open source versions of Unit, which will then, for lack of a better term, kind of remove multiple hops in this by collapsing them down as programmable capabilities running natively alongside the function that you're trying to run.
A quick question from me, Rob. I would want to understand a little bit more who is currently selecting your product inside organizations. With Tech Field Day and the guys here, I've seen a number of different companies with a number of different kind of routes to market. We get some that are kind of that native open source that are really filling the gap that developers must have, and then they're trying to then create an enterprise business to support that model. And we've also got the others that really kind of help with the day two problems, that scale, that performance, and then they're trying to then go back to convince the developers to implement earlier on in the cycle to do that. So as I'm newer to your technology, I was wondering if you could just explain who's selecting the product and maybe how some of your future changes, aspirations are going to change that model.
Yeah, for sure. So if I rewind several years, where Nginx was getting organic pull into organizations were sysadmins who needed to get a web server in place that was faster, more scalable, right? So maybe placing something like Apache or IIS with a web server. So that was how we got our initial footprint. Over time, what we found was that developers were then taking that web server and using some of the proxying capabilities or caching capabilities to offload logic that they would have had to create native in the app, and instead they can just rely on it running as a service they can call from the app itself. So really, in the last couple of years, the majority of adoption has been the developer community, and I use developers loosely. Anyone who's building or scripting an application. So it could be a software engineer, it could be a site reliability engineer who's looking at scripting, it could be a DevOps engineer who's doing things in Python, right? Anyone who's doing that level of customization and kind of treating their infrastructure as code, where it's part of CI/CD, is our focus. Now, to your point, that will always be the focus for open source. We want folks that can build applications that are ready to go in production, and they'll always be able to rely on NGINX open source to do that. We're not saying our open source is for test dev. Once you go into production, you're going to want the commercially supported version. I don't think that genie's ever going back in that bottle, right? If you want to run an open source production application, you should have reliable tooling to do so. There is, and I may steal your term, Barry, there are a bunch of day two problems that then occur once that application has been running in production, is kind of thrown over the transom to a platform team to run it day to day. That's where the commercial versions of our products will come in, is really focused on the day two. But the open source philosophy is more on the builders rather than the operators. I know that line is blurring, so it'll vary, company to company, but that's at least where we're trying to stay committed for today.
So I have a question about that reference architecture app. Is the license to that going to be the same license as open source NGINX or something different?
I'll have to double check what the exact license is. It's actually posted on the GitHub front page, so we can follow it up there. But no, I mean, we want it to be as permissive as possible, right? Just like the original NGINX open source. I don't know if it's using the exact license, but our goal here is to get as much contribution as possible. And, historically, NGINX kind of got beaten up for why we're using such a permissive, because by the way, one of the questions that was earlier around why would you use NGINX versus cloud native? A lot of those cloud native services are built on NGINX. There's a lot of solutions that are built. That's great. What we care about is footprint, runtime, getting folks getting up and running. And so we don't want to limit that at the license end. What we want to do is instead worry a lot more about how do we actually worry for the, again, I'm going to steal Barry's term, the day two problems that occur once you're up and running. We don't want anything that would inhibit it day 0 and 1 for building and deploying.
Okay, great. Thank you.
Yeah,
what I'm wondering is that now that the organizations are experiencing this pandemic, so are you seeing some sort of like a trends coming? So we know that organizations are like focusing more on security and digital transformation, but how are these topics visible for you? So what your customers are valuing?
Yeah, sure. I think I'll try to be careful in the way I say this because I don't want it to come off as insensitive, but in many essences, the pandemic was a boon for folks that needed to build digital products and services. Maybe they were like the phrase that's often said to me by application teams is we built in 6 weeks what would have taken us 6 months to a year to build earlier, because there was sort of an existential, hey, we can't interact with our customers the way we used to. We have to have a compelling digital version of that. And so we saw a big spike in interest and activity, people that were kind of playing with Kubernetes or small microservices or modern patterns, suddenly pushing it into production, whether it was ready or not, and then basically fixing parts of the airplane while it was flying through the air, right? That's another one for you. I'll keep trying them out. So that's, I think for us, we saw a lot of spike in interest. Now, the key is when you have that kind of pattern, you end up with a lot of technical debt that companies are purposely kicking that can down the road. Like, we're just going to put this thing in place. We're going to get it up and running. We're going to get it scaling and secure by hook or crook. And what we find is that now that we're 18 plus months into this, some people are actually revisiting the architecture. They had to quickly get to market, say March of last year, to figure out, was this the most elegant way to solve it? Can I maybe collapse the different components into a more operationally sound architecture? Because to get that speed, what most people did is they just empowered their developers. I'm going to borrow a Gusism. It's like developers are running with scissors. We could sit there and yell at them and say, you shouldn't do that, but that's not the case. They're going to do it anyway. So how can we put guardrails in place and make it safer for them to actually do that? And by the way, in this analogy, running with scissors is making changes to live production applications and rolling those out quickly. So I think that's the trend we're seeing, is how do we do that more safely? We saw a lot of it. And now we're already in a second wave where people are revisiting and trying to consolidate the architecture. Do I really need 5 different proxies, 2 different caching, 2 different APIs, right? That worked when I got it up and running, but each one of those has latency and overhead, and I can probably re-architect it a bit more smoothly.
Yes, and you have to have those like a standard platforms, which are ensuring that you have secure development possibilities there, and that avoids you having like shadow IT trying to overcome these limitations very fast.
Yeah, great point, Katya. And what I'd say is, I think there's a balancing act between allowing developer self-service, but also providing guardrails so that I can get some of the scale and security policies that are needed. I think gone are the days where we can just dictate this is the corporate standard and you have to use it. But I also think the days of just use whatever you want and put it in production ends up increasing, risk and liability there as well. And so there's a balancing act. And so that's why we see so much around the popularity of Kubernetes and making an environment where you can provide developer self-service, but with some of those guardrails in place. And it's very analogous to VMware and ESXi and what they did for VMs 15, 20 years ago. We're now seeing that, but in more of a developer-led phenomenon where Kubernetes provides that platform and a whole ecosystem will be born around it. But that ecosystem will be one where developers get to pull and choose the components that make the most sense to them.
Rob, I have a question about something you mentioned, and maybe it was an off-the-cuff comment. So if it was, just say, it's just an off-the-cuff comment. But you said that the core tenets of NGINX are that it was lightweight, fast, and flexible. And if you had asked me the core tenets of NGINX from my perspective as a user and as an enthusiast for the open source technology especially, I would have said that it was lightweight, fast, and scalable. I wouldn't have, it's not that it's not flexible, but I see the flexibility as sort of a benefit of those other things, but maybe the scalability. Anyway, has it occurred to you, or was that just an off-the-cuff comment?
Both. Every year we go out as part of our interaction with the community, and we do a large-scale user survey. And part of what we ask is, what value are you getting from NGINX? And so those are the top 3. Scalable and reliable are other terms that are often chosen or used. So I think it's fair. I think to me, when Igor built NGINX all those years ago, scalability was the founding principle, right? He wanted to create something that scaled to 10,000 concurrent things. So that is absolutely a valid one to bring up. I think over time, what NGINX has come to mean from a flexibility is it has, or the other thing I've often heard is a Swiss Army knife. It can be many things. It can be an API gateway, a caching server, a streaming server, a web server, et cetera, et cetera. So that I think has sort of eclipsed in terms of recognition of what it does. But what I will say is all that flexibility isn't worth it if it prevents it from doing that core scaling, right? If you're turning on all these features and it bogs down, then it's sort of an impediment as opposed to an accelerant.
Yeah, that's my feeling exactly. Yeah.
And that's why a lot of people actually federate NGINX. And so different instances perform different tasks. So I have one kind of operational framework, but I'm kind of specializing it to do a particular task. And that's how I keep to a core tenet of speed or flex or scale.
Rob, that actually rolls really nicely into the question I wanted to ask. One of the things that was sort of brought up in, I think, Mark Church's presentation from Google was the idea that, to a certain degree, service mesh and app gateway and load balancer and proxy the line is very blurred between all those different functions. And I know you just had a service mesh that went GA. How do you think this blurring of lines is going to impact the different solutions that NGINX has?
Yeah, it's a great question. And, the dirty little secret of so many of these technologies is they're all just proxies by different names. An API gateway is proxying an API call. Load balancer is proxying a session. You've got ingress controller, which is really just proxying those sessions specifically in and out of a clustered environment. And so I think what happened is, as with most technology, you get an explosion of innovation where people are taking it and purpose building a tool for a task at hand. Because that's what gets me to ease of use faster. If I know I need the proxy to act as an ingress controller, then I will build a flavor of it that does that. And so when it spins up, it's already kind of pre-configured. It automatically knows how to talk to Kubernetes operators and so on and so forth. Now what we're seeing is, well, complexity is the enemy of operating at scale. So as Kubernetes really tips over into production, most folks are looking at it and saying, wow, is this complex? Can we maybe collapse some of these things? They're all really doing very similar. So now we're getting pressure from large scale enterprises to get it to the point where these things are doing similar, but maybe there's a common operational framework or there's a common way to configure them. And I would absolutely agree with Mark. I think API gateway and ingress controller are merging. I think sidecar proxies, which if you really wanted to push API functionality to its extreme, would also converge. And so all of those will kind of be, I think, similarly, but I still want to make sure that I'm running the bare amount of functionality needed to be lightweight and fast. And so there'll be some sort of control plane that's deciding what switches to flip on each proxy so that it performs its task, but it will be the same core proxy instance running in all different parts of the network. And I think that's good. I don't think we want to be to the point where there's a best of breed API vendor and a best of breed ingress and a best of breed sidecar proxy, because all of that just leads to that operational complexity. But if I can have best of breed configs for each one of those with one operating framework, and I think that's really, and by the way, we're seeing the API management vendors like Kong are attacking this from one angle. We're seeing that even the Kubernetes platforms are beginning to build some of this in. Istio is coming this direction. So I think we're all arriving on the same end state. We're just taking slightly different paths there.
Right. I've kind of been seeing the same thing from some of the vendors as well. So I'm glad you spoke to that. And that modular approach where you just got a strong core and you snap in the modules for the proxy you need, that makes sense. I love what you said, that they're all just proxies. That clears it up for me. Okay. Yes, they're all doing proxying, just in a slightly different way. So thank you for that.
Yeah. And not to prattle on, but originally one of the reasons why they were also broken out in different products or functions was because different teams owned them, right? I had an API specific team. I had a Kubernetes specific team. And so just because of segregation of duty, well, as with all things technology, as it matures, it kind of sediments down to a common team, right? There isn't, server storage and networking are all kind of common to what the virtualization team could do. That's what this platform or platform ops team is becoming, is they own all of the ongoing operation and maintenance of these things. And so that's when you start getting the desire to not be hyper specialized anymore and really start getting to more common operations.
Thanks, Rob, I think some great answers. And maybe, I suppose maybe you're trying an opportunity to sum up question. I think the more, I started this very much with the idea that why would you use Nginx? What would you be looking at? There's things you can do natively. There's open source projects that maybe do things. But it really strikes me as and there's something you said earlier on about this kind of guardrails idea. But it really strikes me that maybe certainly for the paid products, that your goal is to standardize, make more straightforward, empower the enterprise to deliver these applications, but with a level of control. Is that fair? Is that kind of the NGINX mission, for want of a better phrase?
Yeah, absolutely. That is a good summary. I think to me, there are two primary functions that I think an enterprise needs to remain competitive. They may or may not own them, but it'll be developers that are creating the bespoke digital experiences that kind of attract and retain those customers. And then there'll be the team that knows how to make that application rock solid, kind of bulletproof, so that it doesn't lead to a poor user experience. Today, there's a whole set of delivery technologies in between that are a bit of black magic to a lot of folks, right? It's the absolute best of the best, like a Pinterest or Shopify, know how to do that really well, but the standard enterprise is sort of on the outside saying, I don't think I have that skill set. So I think our mission is to demystify a lot of that delivery technology and make it so that you can actually get developers focus on what they want to do, which is create compelling code, and then empower the operator teams to then scale it and make it reliable without having to have spent 10 years in a cloud native company before they have the requisite skill set. So that's, to your point, that's kind of the mission. And then I think the technological thesis underneath it is, how do we do that in a way that doesn't then hard code you to the underlying infrastructure? Because there is a way you could solve this where you just rely on the cloud native service or just rely on the widget that's built into the platform. But doing so then makes it not portable or makes it harder to scale over time. And so we think of it as we want to horizontally integrate all of those different components as opposed to vertically integrate them and make it as that abstraction layer that sits north of the infrastructure, south of the application. And that's kind of what we're technically building and hopefully making it easier for your average enterprise to get to the point where they have a modern app up and running.
I think if I'm going to take one thing from this, it's NGINX demystifying the modern application. I'm going to have that. You can have that for free if you want.
Okay, I will steal that. In true open source fashion, I will steal it.
I will post it in the appropriate repository. Thanks, Rob.
In true open source fashion, it's donated, not stolen. So you're good.